Welcome everyone. We are working on homework 2.5, equations of motion, and since homework question 1 is a conceptual question, we can talk about that in class, so we're going to be starting with homework 2 right now, homework question 2. So this is set 2.5, and number 2 is what we're going to start out with. So we have a child sliding down a hill on a toboggan, and let's write down our givens first, right off the bat. The acceleration of this child is going to be 1.8 meters per second squared. We're also told that she starts from rest, and so our initial velocity, VI, is going to be 0 meters per second. And this, it appears that this question has 3 parts, but it's really one part with just 3 different values to punch in. Parts A, B, and C are all the same calculation, just with different values of time. So let's start by writing down for A. It tells us that the change in time, or the amount of time that is elapsed, is 1 second. And so what it's asking is, what's the displacement at A? That's what we want to try to find out. Well, the same is true of B right here. We're told that change in time at B is equal to 2 seconds, so we need to find the displacement at B as well as at C. So C, put down here, change in time at C is 3 seconds, so it's up to us to find the displacement at C. Well, let's go back to A and write down, well, we've already written down what we know, but what we need to do now is find an equation that relates all of these values. We have our A, acceleration, we have our initial velocity, we have our time that we're told at A. So the displacement for that is what, and what would the best equation be? Well, if you look through all the 5 that we have derived, you'll find that the one that fits the best is, I believe, equation number 4, where it relates the displacement to time, initial velocity, and acceleration. That goes like this. Our displacement A is equal to initial velocity times t of A, at A, plus 1/2 times the acceleration times time A squared. So this will actually simplify down a little bit. So let's put some numbers in here. So our displacement at A is going to be equal to 0 meters per second. That's our initial velocity, right? And that'll be handy because 0 times anything is 0. But just for clarity's sake, I'm going to put in the time anyway, times 1 second, plus 1/2 times the acceleration, which is 1.8 meters per second squared. That's our acceleration A, times the time at A. Oops, I already wrote that. What is the time at A? It's 1 second, right? But that whole value is going to be squared. So times 1 second, the value squared. Well, we're going to see right now that our initial velocity times time is going to go away because it's equal to 0. So I'll rewrite this. Displacement A is going to be 0 plus 1/2 times 1.8 meters per second squared times 1 second squared. And if we punch that into our calculators and calculate it out, it's going to give us a displacement at A of 0.9 meters. All the other units are going to go away, and we're simply going to have an answer in meters. So that's our displacement at A. Let's try it at B now. Well, the same equation is going to be used. Our displacement at B is going to be initial velocity times time at B. There should be a lowercase b there. Plus 1/2 times the acceleration times time at B, lowercase b, that value squared. So again, our displacement at B will be 0, because again, that's going to go away. Plus 1/2 times the acceleration, 1.8 meters per second squared, times our time at B, which is now 2 seconds, that whole quantity squared. So that's going to come up with our displacement at B equaling 3.6 meters. And now finally at C. Our displacement at C is equal to initial velocity times time at C plus 1/2 times the acceleration times the time at C, that value squared. Again, that'll go away. You probably already knew that. Displacement at C is going to be equal to 0 plus 1/2 times 1.8 meters per second squared times our time squared, which is now 3 seconds squared. So of course, when you punch all this into your calculator, you won't have units to punch in, but while we're writing it out, we should write it out in units. And if you look at all of your units, you'll find that, well, like above here, our units wind up being in meters, when that's a unit of displacement. So our displacement C is going to wind up being 8.1, oops, that's 81, 8.1 meters. 8.1 meters. So, homework 2.5, number 2, parts A, B, and C are respectively 0.90 meters, 3.60 meters, and 8.10 meters.